let's look at the dots factoring pattern, which is used for binomials, so polynomial with two terms, something like x squared minus 9. And dots stands for the difference of two squares. So that's where the DOTS comes from. It's just easier to say dots than the whole mouthful difference of two squares. I say the difference, that obviously means subtraction, and you're looking for something that has two perfect squares. So perfect square would be x squared, x to the fourth, x to the sixth, anything that's even, okay? And it's got to be a minus sign, and then you need perfect squares. Well, what are your perfect squares? That's 1 squared, 2 squared is 4, 3 squared is 9, could be 16, 25, 36, 49, 64, 81, 100, and they keep going, okay? They come from squaring integers. So let's do a quick flashback of when we multiply two binomials together. What do we get? So if I have something like x plus 5 times the quantity of x minus 5, what I do here is I distribute. First, I distribute this x, which gives me x to the second minus 5x. And then I distribute this positive 5 to everything in the second, which gives me plus 5x minus 25. And what happens here? These two middle terms drop out, and I get x squared minus 25. So what am I going to be doing now? Well, I'm going to give you this simplified version right here, the x squared minus 25, and I'm going to say factor, which means you've got to back up and give me this first line of x plus 5 times x minus 5. So on your graphic organizer, you already know that the first method is the GCF. Let's zoom in, and I'm going to show you the factoring pattern for the difference of two squares, or the dots pattern, which the pattern looks like this. It says, if you have something in the form of a squared, it has to be minus b squared. Okay, so that's two perfect squares, and it has to be subtraction. This factors into two binomials. Okay, so two things multiplied together. All you do is you take the square root of the first. So the square root of a squared would be a, and you put that in the first term. Then you take the square root of b squared, which would be b. That goes as your second term. And the pattern says one binomial has a plus and the other has a minus. It doesn't matter if you put a plus b first or a minus b first. All right, so let me show you one or two quick examples here for the front of your organizer, and then we'll get into more detailed examples. So if you have x squared minus 49, check and see, is this dots, meaning is it a difference? Yes. Is this a perfect square, and is this a perfect square? Yes. So the pattern says this factors into two separate binomials. Take the square root of x squared, put it here. Take the square root of 49, here, it's 7, and the pattern is one's a plus and the other is a minus. So x squared minus 49 factors into x plus 7 times x minus 7. Let's show you one more quick example. So let's say you have 4x to the second minus 9y to the second. Again, you're checking, is this a perfect square? 4 is, so is x to the second. I've got a minus, so that's good. Perfect square, perfect square. So yes, this is the dots pattern, and it factors into two separate binomials. You take the square root of each. So the square root of 4x squared is 2x. That goes here and here. Pattern says one's a plus, the other is a minus. And the square root of 9y squared is 3y. So one binomial is 2x plus 3y, the other is 2x minus 3y. Okay, so if you can flip to the back of your graphic organizer, we're going to do some practice. I want to remind you, if the GCF is your first factoring method, we're going to get in the habit of always first deciding if there is a GCF. Well, coefficient here is 1, so I'm not going to ever pull out 1. Y squared, there's no y here. So then I go on to the second method, which is dots. Is it a perfect square? Yep. And 121 is a perfect square, and it's a difference. So this is the dots pattern. So we're going to split this into two separate binomials. We take the square root of y squared, that's y. The square root of 121 is 11, and one's a plus and one's a minus. Now, I do remind you, if you're not good with perfect squares, you just type in root 121 into the calculator and it will output 11 for you. All right, number 8 on the back. The GCF, is there anything that goes into both 4 and 9? No. And I don't have an x squared in both places, so then I check for the dots pattern. Do I have a difference? Yes. Is it a perfect square? 4x squared? Yep. Is 9 a perfect square? Yep. So this factors into 2 separate binomials. I take the square root of each term. Square root of 4x squared is 2x. Put that first. Square root of 9 is 3. And the pattern says one is a plus and the other is a minus. Okay, next one, y squared plus 49. First of all, is there a greatest common factor? Nope, nothing goes into both y squared and 49. Then I check for dots. Well, I have a plus sign right here. It has to be a difference or it is not factorable, okay? This is a prime polynomial, just like when we have numbers and we break them down. If they can't be broken down any further, then it's prime. All right, number 10. Again, first we look for a GCF. Well, I think we have one here. 3 and 27, there's something that goes into both. And I have an x cubed and an x. So I'm going to begin by factoring out the GCF, which is 3 goes into both 3 and 27, and x goes into both x cubed and x. So I open up a set of parentheses, and I'm going to divide each of these by 3x. So I'm doing the GCF. That gives me x to the second minus 9. Okay? Now, I'm not done. I can do another step here because what's remaining? Well, this x squared minus 9 here in the middle, it's a binomial, so we should check for the dots pattern. And it is. It's a difference of 2 squares. So I'm going to factor this further, but I need to make sure you recognize, bring down this 3x, okay? Don't drop it. But I'm going to open up this 2 sets of parentheses to take the square root of x squared is x, and the square root of 9 is 3, and the dots pattern says one's a plus and one's a minus. So this gets factored into these 3 separate polynomials, 3x, x plus 3, and x minus 3. All right, that one's pretty cool. All right, now let's take a look at 8x squared minus 50. So again, we begin by looking for the greatest common factor. What goes into both 8 and 50? Well, at least 2 does, right? Because they're both even. Does 4? 4 doesn't go into 50 evenly, so let's start with 2. All right, so put the 2 out front. And when I divide by 2, I get 4x squared minus 25. All right, sweet. 4x squared minus 25. That looks like the dots pattern to me, okay? So I'm going to take a look at this. Sure enough, that is dots. Oops, the dots pattern. So I bring down this 2, and then I open up 2 sets of parentheses for the 4x squared minus 25. Let me just give myself a little more space here for you to see. And the square root of 4x squared is 2x, so I write that first. The square root of 25 is 5, and the pattern says one is a plus and the other is a minus. So these 3 factors completely factor my polynomial. All right, this next one, I'd like you to pause and try it on your own. So you should have begun by finding your GCF, which when I look at this, 7 goes into both 7s, and then I have an x to the 5th and an x. So at least x to the first gets pulled out for your GCF. So 7x is my GCF. So I begin by dividing each of these by 7x, which produces x to the 4th, keep your base and subtract your exponents, minus 1. Now, maybe you got stuck here because you didn't know how to take the square root then of x to the 4th. This is a perfect square. If it's to an even exponent, you can cut it in half. And 1 is a perfect square, and this is a difference. So we bring down the 7x, open up 2 binomials, and we do have the dots pattern with this x squared minus 4. All right, so the dots pattern says it becomes x to the second is the square root, because x squared times x squared would be keep your base and add your exponents. You get x to the fourth, and the square root of 1 is 1, and the pattern says 1 is a plus and 1 is a minus. So it's factored. But look closer. This is an amazing one. Check out this right here. X squared minus 1, I actually have another perfect, or another dots pattern. The first one is a plus, this x squared plus 1, so I just bring this straight down. But this one here, love this, breaks up into two more. I take the square root of x squared, which is just x, the square root of 1 is 1, and the pattern says 1 is a plus and the other is a minus. So check out this amazing factored problem. As always, if you're struggling, make sure you reach out with questions. You definitely need to practice this to make sure that you've got it.